So what we try to do here is that we actually want to have a mechanism for us to actually carry out all these different functions. And first and foremost, all these different functions is very straightforward. It's coming from a stack by of its own. But suddenly you have like this item get minimum. It therefore become really tricky, because what this item does is that you're getting item out of nowhere. What I mean by that is that you need to have a mechanism for you to run through the whole mechanism, like you run through the whole system to actually find out the minimum data. And usually for this case, it's very inefficient because it takes up a big O of n time complexity, and you need a smarter way, which therefore they actually introduce the minimum stack. So we are calling this stack 2, a second stack, just to get the minimum. Because if you want to get a big O of 1 complexity, that's what you actually have to do for it. But in the overall grand scheme of things, what we're actually having over here right now is that well, first and foremost, using the mechanism of having a stack. And right now we're also using another way of getting an item, which is the get the minimum at a very awkward position from a stack, which require big O of n. That's why we have to think creatively on how we actually gonna do it. So therefore we actually introduce another item called stack number 2 to actually help us to actually fulfill this get minimum item. So if we were to actually talk about all these items, it was like actually meeting this condition of having said that we do want to get the minimum. That was our condition that makes us think a lot. And we therefore come up with the solution of saying that okay, why not we do a stack number 2, as opposed to what? As opposed to having this way of saying that use the brute force, which is run through the whole entire system to actually check for the value. So we try to be very efficient. So you can argue that we can surely use this brute force way to actually check one by one. But if you were to think of like very small time complexity, we use the stack number 2 for it. So if you see deep, they do actually talk about how they use the mechanism of like a stack number 2 corresponding with the original stack of its own. So if we were to actually zoom in to actually talk about this, is that okay, they bring in the in array item to actually start doing a comparison. So they bring in a -2, and then they bring in a 0, and then the thing is that when you bring in a -2, sure, the minimum value is -2, but when you come to here, like if you were to do like a normal traditional way, the item wouldn't know that which item is your minimum. So you only know like what is the item that is like on top of the stack, which is a 0, right? Which is a big or fun operation. You can get the on top of the item of a stack. So now here's about to come a trouble. So you bring in a -3, okay. Then what if you say you pop this because this item is your now newest negative new minimum item, right? But what if you pop it? Now what is your current most minimum throughout this entire stack? The only item that you can access is only the on top value, which is a 0, right? When visually you see is a -2, that's the minimum. But for your stack point of view, you only can view your top value, which is a 0. You wouldn't know that your -2 is your minimum value. So that's the problem. So therefore, as opposed to this, you introduce this new item, which is the minimum stack item, which is that, so you plant a -2, you actually start counting which item is -2 the more than the current minimum, because it's empty, it's definitely it is. And then you come to here, you compare the new value, the new 0, because you insert just the new 0, right? Compare with your latest minimum, which one is lower? And -2 is lower, right? So plant a -2, you plant a -3. -3 compared to your last minimum, so it's a -3, it's smaller. And so like, even though if you were to actually start popping off your -3, which eventually you will pop this one as well, you'll be able to know that, okay, what is my minimum throughout my entire stack. You do know that -2 is your current stack, as opposed to having not recorded and then you will register only the top item, which is a 0. So basically that's the main difference. That's why you need the stack tool for you to start tracking on the whole item. And that's the whole the main idea of like this question, that what you actually want to do is that you want to introduce the stack number 2 to actually fulfill your this condition, this very unique condition of wanting to actually check for the get minimum. But on top of all this condition, you also need the few of the basic properties, such as pushing, and then you need to pop the value as well. So I mean, these two can already be fulfilled by having like a stack item. That's why you bring in to use the stack to actually try to solve the problem, because this is the properties of a stack, and that's why you bring in a stack. So yep, with that everything comes to an end.